I welcome you all to this session on random cloudlet scheduling to improve CPU time and mean span in cloud environment using shortest Java scheduling algorithm. We will be discussing about abstract introduction, scheduling algorithm, proposed method used here, and simulation result and conclusion. As we all know, that cloud computing is becoming very important in all the domains and applications. We need to do some improvement in scheduling cloudlet and allocating resources in order to complete the cloudlet. So here the cloudlet means task, the request from the user. If the request from the user is getting increased, how we are going to allocate the resources needed in order to complete the task? That is the scheduling algorithm. And here the mapping of virtual machine with cloudlet is very important. We are focusing to reduce the overall time, the span and CPU time, in order to increase the resource utilization and improve the performance. Here in this study, we have proposed shortage of first scheduling algorithm to execute cloudlets and have introduced random delay in order to get the feel of real-time user request. This open sources CloudSim simulation tool is used, and the proposed algorithm improves CPU time and mean span compared with round-robin scheduling algorithm, which is the one by default used in simulation tool. So we all know that cloud computing is used in all the technology and it is promoting for future economy. So here the service provider means one who give the resources in order to execute our services. So what they'll do, they have their own data centers. So they'll be investing a huge amount in order to maintain hardware, software, and applications, and they provide user-friendly services. So the services will be delivered 24/7, all the 365 days. And resources as well as applications will be provided to the user from anywhere at any time, and it is based on pay as you go model. So here, basically, there are 4 deployment models are there: private cloud, public cloud, community cloud, and hybrid cloud. And when we come to the different services offered by the service providers, majorly we can divide into 3 types, that is infrastructure as a service, platform as a service, and software as a service. Nowadays, everything is provided as a service, like the data is provided as a service, security is provided as a service, hardware is provided as a service, network is provided as a service. So everything can be provided as a service. So here in this algorithm, shortage of scheduling algorithm, we are going to execute heterogeneous cloudlet. So it will be of different size, and it will be allocated to the virtual machines available in the data center, and we are going to see how it is getting improved. So here that we have used the CloudSim simulation tool. It has many good features in giving us the when we do for a simulation and the experimentation, it comes with very good result and supports us in all the ways possible. It provides features like helping us for modeling and simulating large scale cloud computing environment, which includes creating data centers and computing nodes. And here it provides a platform for modeling cloud service brokers, allocating the resources and provisioning the resources. And here it supports for simulation of network connections and also provide the facility for simulation of federated cloud environment. So this is the flow of the cloud simulation. So here if you see cloudlet, as I said, it is the task. So when we have request, we user, what we need to do, we'll be submitting that request to the broker. Broker, what he will do, he will contact the cloud information service. So what will be available in the cloud information service? The details about data center. So number of resources available in the data center and the storage capacity, about new softwares available in the data center. Everything will be registered here in this cloud information service. So as I already said, in a single machine, we can create number of virtual machines. Each virtual machine will be allocated for individual cloudlet to be executed. Okay, so here about the available resources and application of the data center will be registered in the cloud information service. So what the broker will do after receiving the cloudlet, broker will communicate this cloud information service and they'll come to know where the resources are available and the application what it is needed to execute that cloudlet is available. Those information will be collected from this cloud information service. And then what the broker will do, they will send that cloudlet to particular data center and there it will be executed and the end result will be given to the users. Okay, so here the flow will be like that. First, we'll be initiating the cloud simulation and we'll create the data center and data center broker will be creating and then we'll create number of virtual machines and cloudlets and it will be added to its list and we'll submit this virtual machine and cloudlet to the broker and we'll start simulation and execute it and we'll stop it and we'll get the output. So here we'll discuss a few scheduling algorithms. We all know that this scheduling is very important and in decision-making process when we execute the cloudlets. Okay, where the virtual machines will be allocated for the number of cloudlets to get executed. So due to resource constraints, cloudlet scheduling is challenging problem. So these heuristic algorithms are rule-based and it is widely used in infrastructure as a service platform. And first about first come first serve, this scheduling algorithm is aiming for scheduling the resources. See all the resources no need to wait for a long time in the queue. The cloudlet which is coming first will be executed first. So always it is very good method when we go for parallel processing. So here this first come first service is the default policy implemented in CloudSIM to provision the virtual machine. So here the drawback is the shortest cloudlet has to wait for the long cloudlet to get executed. That is the drawback. To overcome that, we'll go for this round robin scheduling. In round robin scheduling, it is like a ring as a queue. Okay, so here what happens, each cloudlet will be in the queue given same execution time. And if the cloudlet is completed or not, after that allotted time, it has to go back again. If it is not completed, it has to go back and wait until it turns comes. Okay, so like if, as I said, if the cloudlet is not completed, then it has to wait for its next time. And here CloudSIM support round robin scheduling strategy in order to schedule the cloudlet. The drawback of this round robin is that largest cloudlet takes more time to complete its work. So here in our proposed method, we are using shorter job first scheduling algorithm. So what we are doing here, first what we need to do, first we have to create a virtual machine to the data center according to its computational power. Okay, so we'll be considering the factors like cost, the processing speed, memory, and processes, number of processes we are using, and the storage capacity. We have to consider, and then we have to create number of virtual machine in the data center. So whether we are going to use one data center or multiple data center, that we need to decide. Then we have to generate cloudlet with different length in order to get heterogeneous cloudlet. So then we need to sort that random cloudlet in ascending order based on its length. After that, we are introducing delay in the cloudlet summation in order to get the real-time fee, user request fee. And the sorted cloudlet is submitted to the virtual machine by data center broker and we'll start execution and we'll get the end result. So this is the simulation we have done. So the capacity of that system and the version of the CloudSIM is 3.0.3. And here we are considering the factors like total CPU time, wall clock time, and make span. And we also, based on this summation time, execution time, start time, finish time only, this will be calculated. So here it is repeated for 10 times. We have taken these parameters and see when we see the result, wall clock, this is the performance of shortage of a scheduling algorithm, and this is the one for a round robin scheduling algorithm. And you compare this wall clock throughput and CPU throughput and make span. So you see it is increased, the performance is increased, the time is reduced compared with the round robin. So you see here about CPU throughput. So if you consider, see here, while executing the cloudlet, see constant CPU throughput you could see, and the clock time used is very constant. But you see here, while starting only it is high, then it reduces as per the number of cloudlets, it is getting increased. So the performance is increased here. But here, if you see, it is occupying more CPU time. So in the same way for a wall clock time. So you see here, so it is getting improved. And here this is the performance result of make span. Okay, so overall here in this shortage of a scheduling algorithm, the CPU time and wall clock time, max span time is the performance is increased, means the time is reduced and the performance is increased. So here this shortage of a scheduling algorithm is performing well compared to round robin algorithm. In the future, we could analyze with a different type of dynamic scheduling algorithm in order to get better performance in real world application. Thank you.